So today I would like to discuss a concept of projectile motion, and it is like this. Like we have thrown a particle at an angle theta with velocity u, and it is performing a motion like this, right? So now we want to calculate few things about it, like projectile motion. So we want to calculate few specific things, like first of all time of flight. Basically the time in which particle has been in the air. Second, maximum height achieved by the particle. Maximum height which is achieved by the particle. And third, range. So basically horizontal length which is covered by the particle in time of flight. So basically this is the range of the particle. Okay, and this is the maximum height of the particle. And in this duration, the particle covers the particle which particle remains in the time t is time of flight. So basically particle has velocity u. So particle has velocity in two directions here. If we see in the components, this is ux, which is nothing else u cos theta by component methods, and this is uy is equal to u sin theta. So now you can actually see that there is no role of u cos theta, that particle is going in upward direction. So basically, in order to calculate capital T, we are focused on uy, and of course particle has gravity is working in this direction. So if I want to calculate that particle went up to height capital H, then I can write S is equal to u plus ut plus at square. This is one equation, and we can have v is equal to u plus at. So here I can actually see that I need this second equation, v is equal to u plus at. So v is equal to u plus at in upward direction. So basically Vy is equal to uy minus g into t by taking upward direction positive direction. This is our convention. So basically Vy will be 0 when particle achieves maximum height, and uy is u sin theta minus g into t. So from here t is equal to u sin theta by g. So this is the time which particle takes in order to go upward. So now this particle will take the same time in order to come down. That means time of flight will be is equal to 2 into t. So that will be 2 into u sin theta by g. So this is the formula which is very, very important. The students should remember this. Okay. Now we want to calculate maximum height achieved by the particle. So this is our diagram, u, ux, uy, and this is angle theta. So this is the height which we want to calculate. So how should we calculate it? So the point is that we have the second equation, okay, and we also have the third equation. So we can use third equation, v square is equal to u square plus 2as. So equation of motion, this is the third equation which we have. Now we know that in upward direction, particle will have zero velocity at the top, as we have already seen. Then 0 is equal to uy square minus 2gh. So there is h is equal to uy square by 2g. So this will be u square sin square theta by 2g. So this is also very, very important, which needs to be remembered. by the particularly student. Okay, because sometimes question can directly come while using this formula. And then if we want to calculate the range, so range can be calculated simply r is equal to uxt plus half ax into t square. But ax is 0 because there is no acceleration in horizontal direction. So basically ax is 0, that means r is equal to ux into t. So ux into capital T, that would be is equal to u sin theta into 2u sin theta by g. So basically range will be is equal to u square 2 sin theta cos theta by g. So this will be u square sin 2 theta by g. So guys, remember this formula. It is these three formula are very important in order to solve question based on projectile motion. Thank you.